Good day. My name is Lethabo. My surname is Today I will be doing revision the grade 12 mathematics revision with you. I'll be doing revision with you. Question 1. Question 1. Q1. Question 1. They say f of x is equal to x squared minus 3 times 3x minus 1 times x plus 2, then 1.1. They say solve for x if f of x is equal to 0. 1.1.1. Solve for x if x is an integer. Then if x is an integer, that means x must be the whole number. I will be having x squared minus 3 times 3x minus 1 times x plus 2 will be equal to 0. Then x squared minus 3 will be equal to 0, or 3x minus 1 will be equal to 0, or x plus 2 will be equal to 0. Then x will be equal to the square root of 3, or x will be equal to 1 over 3, or x will be equal to negative 2. But since x is an integer number, therefore x will be equal to negative 2. I hope you understand. Then let's jump to question number 2. 1.1.2. It says that solve for x if x is an irrational number. An irrational number refers to a fraction number where the denominator is not equal to 0. Then we have x squared minus x squared minus 3 times 3x minus 1, which is 3x minus 1 times x plus 2 is equal to 0. Then for a rational number, we will have x squared minus 3 is equal to 0, or 3x minus 1 is equal to 0, or x plus 2 is equal to 0. Then x will be equal to the square root of 3, or x will be 1 over 3, or x will be equal to negative 2. But therefore, since we are talking about the rational number, x will be equal to 1 over 3. I hope you understand. Why are we saying x will be equal to 1 over 3? It's because the rational number refers to a fraction number. It refers to a fraction number where the denominator is not equal to 0. I hope you understand. Let's go to 1.1.3. They say calculate solve for x if x is a real number. A real number includes a rational number. It includes a rational number, and the rational number and positive or negative number. So x squared minus 3 times 3x minus 1 times x plus 2, which is equal to 0, which is equal to 0. When solving for x will be equal to the square root of 3, or x will be equal to 1 over 3, or x will be equal to negative 2. Since x is there, what is the real? I hope you understand. Why are we saying x is equal to the square root of 3? Because x squared is equal to 3. And when you want to solve for x, then you include a square root. You include a square root on the left side and on the right side, where x will be equal to plus or minus the square root of 3. Now, hope you understand. Let's go to number 9. Next to the next page. We have 1.2. Question number 1.2. They say solve for x. They give us minus 15x squared. Minus 15x squared minus 9x minus 9x plus 4 is equal to 0. And they say correct to 2 decimal places. To 2 decimal places. Already you can see that this kind of question is used to use a quadratic formula which says x is equals to minus b plus or minus the square root of b squared minus 4ac. Divide the whole statement by 2 times a, where x is equal to, always our b is the one with the single x. We're gonna have minus times our b, which is minus 9, close brackets, plus or minus the square root of what? The square root of minus 9 all squared minus 4 times what? 4 times our a always is the one with x squared, which is minus what? Minus 15 is coefficient times what? Times our c is the one with no x, which is positive 4. Then the whole statement divided by what? Divided by 2 times what? 2 times minus what? Minus 15. Our x will be equal to negative times negative, which is positive 9, plus or minus the square root of how much? Then press calculator. You say minus 9 squared minus 4 times minus 15 times 4, which is positive 3, 2, 1. Divide the whole statement by 2 times minus 15, which is minus 3. Therefore x will be equal to 9 plus the square root of 3, 2, 1 divided by minus 30, which is 0.89, or x is equal to 0.2. I hope you understand. Then let's go to question. Question number 1.2.2. 1.2.2, which says 3x minus 2 to the power 2, which is greater than or equal to 3x. When facing this kind of question, first of all, try to eliminate the complex situation. You can see on the left hand side we have the complex situation, so let's try to solve it before. So we can see we have 3x minus 2 in brackets all squared. That means there is 2 pairs of brackets. There is 2 pairs of brackets. 3x minus 2 times 3x minus 2 which is greater than 3x. I hope you understand. Then 3x times 3x, which is 9x squared, minus 3x times minus 2, which is minus 6x minus 6x plus 4, which is greater than 3x. Then we have 9x squared minus 12x minus 12x plus what? Plus 4. Then you transpose 3x to the left, which is going to be minus 3x, which is greater than 0. Then you will be left with 9x squared minus 12x and minus 3x, which is minus 1, which is minus 15x plus what? Plus 4, which is greater than 3. And we have the factors of what? Then you can factorize this by opening 2 pairs of what? 2 pairs of brackets, which is greater than what? 3. So the factors of 9x squared is 3x and 3x, and the factors of 4 is 2 times 2, 4 times 1, but look, we must get what? Minus 15. If I put my 4 here and I put my 1 here, let me try to add this space. My 1 here, 3x times 3x, which is 9x x squared. Then 3x times 3x times 1, which is 3x, which is 3x. Then 4 times 3x, which is 12. This one is times this one times this one, it gives you 3x. Then 4 times, okay, I'm gonna have 3x squared. There was one you need 3x. Then this one and this one, 4 times into it gives me 12x, which is 15. Do you understand? So if I put my minus here, I should put minus here. I don't know if you understand. Should put minus here. Make sure that you understand. Yeah, we're gonna have 3x times this one, which is 9x squared. Then this one and that one gives me negative 3x, which is minus 3x minus 12, which is minus 15. Then you do the timeline, and you're gonna have x where is less than or equal to 1/3, or x is greater than 4/3. I hope you understand when doing the timeline. And let's jump to let's jump to question 1.2.3, which says 5 to the power x, which is equals to 5 times 4 plus 5 to the power 2 minus x. Let's solve for x. When solving for x in this kind of question, you work like this. And we're gonna have 5 to the power x, which is equals to, you make sure that 5 times everything in the brackets go. That means we're gonna have 5 times 4 plus 5 times 5 to the power 2 minus x. I hope you understand. Also, doing this kind of question means you to know the laws of expanding. You're gonna have 5 to the power x, which is equals to 5 times 4, which is 20, plus 5 times 5. Then we apply the rule of exponent, which is 5 to the power 2 times 5 to the power minus x. And 5 to the power minus x is the same as 1 over 5 to the power x. You're gonna have 5 to the power x, which is equals to 20 plus 5 times 5 to the power 2 divided by 5 to the power x. I hope I'm Then we let 5 to the power x equals to k. Where you see k, you substitute. Where you see 5 to the power x, you substitute with what? With k. We're gonna have k, which is equals to 20 plus 5 to the power 2 divided by 1 by k. Then you divide the whole statement. You times the statement of by k. I hope you understand. K times k, gonna have k squared. We're gonna have k squared equal to 20k, plus 5 times 5 to the power 2, which is 125. So we're gonna have k squared minus 20k minus 125, which is equal to 0. Then you start 2 pairs of brackets, which is equal to 0. The factors of k is k and k. The factors of 125 are 25 times 5, which is 125. If I have 25 here and 25 and 5, k times k gives you k squared. 25 times 5 is 125, and 5 minus 25 gives you what? It gives you minus 20. I'm gonna put positive here and minus. I hope you understand. I put positive there and negative there. Therefore, k minus 25 is equal to 0, or k plus 5 is equal to 0. Then k is equal to 25, or k is equal to negative 5. Then remember k is equal to 5 to the power x. The way you see k, you substitute with 5 to the power x, which is equal to 25, and 5 to the power x, which is equal to 25. And you can change 25, not 2 to the power 5. 25. You can change 25 in terms of base 5. And 1 is equal to 5 to the power 5 to the power to the same as 1. It is the same as 25. So will be equal to twice same base, same base equal same base equal x1. Example 1.3. This is all for x and y. The log of what? The log of x to the power 16 is equal to 4 and y plus the square root of 1 x plus 7, which is equal to x plus 1 gives you x, where x is greater than 1 is greater than or equal to. This kind of is multinomial equation. We all know that this is x to the power 4 is equal to 16. It is equal to 16. Then and we can change this into the power of x to the power 4 is equal to 2 to the power 4, which is 16. Therefore x will be equal to 2 to the x will be equal to 2. You can name it equation number 2. This one is equation number 1. Let's check the next page. Then if x is equals to 2, we named equation 2. Equation 1. Then y plus the square root of x plus 7 is equal to x plus 1. But we can name this equation 3. But where we see x, we sub with 2. Equation 2 into 3. I'm gonna have y plus the square root of the square root of 2 plus what? 2 plus 7. The square root of 2 plus 7, which is equal to 2 plus 1. Then y plus the square root 2 plus 7, which is 9. Which is 9, which is equal to 3. The square root of 9 is 3, which is equal to 3. Then y will be equal to 3 minus 3, which is y equal to 0. I hope you understand. Let's look at question 1.1.4. which says calculate the two numerical values for p. For p where x squared plus p 2x plus 7 plus 8. It's a perfect square. A perfect square. It is a perfect square. We're gonna use the delta which is equals to b squared minus 4ac. But before using this formula, let's first solve our equation and make it simple. We're gonna have x squared. We're gonna have x squared plus, then you can see that p is gonna times everything that is in brackets, which is gonna have 2xp plus 7p plus 8. I hope you understand. Where x squared will be our a and 2xp will be our b, and the whole 7p plus 8 will be our c. I hope you understand. And we're gonna have delta which is equals to our b is equal to 2p all squared. That x represents b minus 4 times a, which is 1 times our c is 7p plus 8, which is equals to 2p times 2p, which is 4p squared, minus your open brackets 4 times 7p plus 8. I hope you understand. Equals to 4p squared minus 4 times 7 gives you minus 28 minus 4 times 8 minus 32, which is equal to what? Equal to 0 because of the perfect square. Then you can divide the whole statement by 4. Then we're gonna have p squared minus 28 divided by 28 divided by 4, which is 7 minus, which is 32. So because 8 times 4, which is 32, then 32 divided by 4, which is 8, equal to 0. Then you do 2 pairs of brackets, which is equal to 0. The factors of p, which is p, and which is p. The factors of 8, which is 8 times 1, which is 4 times 2, but we are looking at minus 7. I'm gonna have 8 and 1. I'm gonna have positive 1 and minus 8, because 1 minus 8 gives you negative 7. Then p minus 8 equal to 0. Then p is gonna be equal to 8. Or p plus 1 equals to 0. Then p is equal to negative 1. I hope you understand. Then let's look at question 2. The question 2, we have minus 3, minus 2, minus 3, minus 6, minus 11. They told us is a quadratic pattern. They told us is a quadratic pattern. Question 2.1 says determine an expression of the nth term. We want the nth term of the first difference. And always know that the first difference, it is the linear graph, always. Then we're gonna have minus 3, minus 2, minus 3, minus 6, minus 11, minus 2, minus 2, minus 3 gives you positive 1. Then minus 3 minus 2 gives you minus what? Minus 1. Then minus 6 minus 3, which is minus what? Which is minus 3, which is minus 5. I hope you understand. Minus 6 minus 3, which is minus. When calculating the nth term, we want the nth term. Our a is what? Is 1, and our d is t2 minus t1, which is equals to minus 1 minus 1, which is equals to minus 2. Then the tn is equals to a plus n minus 1 times d, where our a is 1 plus our n, we don't have n, minus 1 times our d is negative 2. I hope you understand. Therefore tn will be equal to 1 plus, and negative 2 is going to times with n, which is minus what? Which is minus 2n. And minus 1 times minus 2 is going to be plus what? Plus 2. It's gonna be plus. Gonna have 1 plus minus 2n plus 2. Then our tn will be minus 2 and plus 3. I hope you understand. Then jump to the next question. Then we have 2.2. Our 2.2, calculate the first difference. We want the first difference of the 35 and the 35 nth term, the 35 and 36 term of the quadratic, where tn is equal to minus 2n plus 3. Where you see n, you substitute with what? You substitute with 35. We're gonna have t of 35, which is equal to minus 2 times 35 plus 3, which gives you minus 67. I hope you understand. Let's go to 2.3. They say determine the what? We determine an expression for the nth term of the quadratic. They want the nth term of the second difference. Where we had 1 minus 1 minus 3 minus 5. Let me go check and again to verify. Minus 1 is good. Then we're gonna have the second. This is the first d1, the first difference. So now we are looking at the second difference. 1 minus 1 minus 3 minus 5. Then we want the second difference. Minus 1 minus 1 minus 1 minus 1 gives you minus 2. Then minus 3 minus 1 gives you minus 2. Gives you what? Minus 2, which is the d2. I'm pretty sure you understand. the d2, the d2, and d1 of the general term of the quadratic, which is Tn, is equal to what is equal to an squared plus bn plus c plus c, where a is equal to d2 divided by 2. A is equal to, our d2 is minus 2 divided by 2, which is a equal to negative 1. I hope you understand. Then we want to b is represented by 3 times a plus b, which is equal to t2 minus t1. I hope you understand. And let's go to next page, where 3a plus b equals to t2 minus t1. Our a, 3 times a is negative 1 plus b, which is equal to t2 minus t1, which is let's go and check, which is positive 1, which is positive 1. Minus 3 plus b, which is 1, b is equal to, I hope you understand, t1. Then we short with c, and c is represented by a plus c, a plus b, we call it a plus b plus c, which is equal to t1, where a is minus plus b, which is 4 plus c, which is equal to our t1 from the original. Our t1 is equal to, let's go and check our t1 from there. Our t1 is what? Is minus 3, which is minus 3, then 4 minus 1, which is minus 3 plus, which is positive 3, plus c, which is equal to minus 3. Then c will be equal to minus 3, which is equals to minus 6. Therefore our Tn is equals to minus n squared plus 4n minus 6. I hope you understand. Then let's go to question number 2.1, which is question number 2.4. Question number 2.4. Explain why sequence never contain a positive term. Because a sequence cannot contain positive term, cannot contain positive term because of a maximum or the turning point with no positive term. Positive term. Above, okay, let me finish it. Choose 2.1, above the x exists, because if Tn is equals to minus n squared positive 4n minus 6, at the maximum point always is equal to 0, which is equal to minus, then you start derivating minus 2n plus 4. Then we have minus 4, which is I transpose minus 4 to the left. We have 2 minus 2, and then we divide it by minus 2 by minus 2, and equals to n equals to what? Positive 2. Then you sub 2 into original equation, which is t2, which is equals to minus 2 to the power 2 plus 4 times 2 minus 6, which gives you minus 2. I have 2 and minus 2. I hope you understand. Then let us look at question 3. Question 4. I'm looking at question 4. Let me upload question 4. Question 4. Let me upload the graph. These are. Then let me upload again the questions, which is question 4. Then question 4. Okay, let me start writing on the next page, which is Q4, which is 4.1. Write down the values of P and Q. Our P and the Q. Always remember, asymptote of Q never change. Only the x-axis changes. Okay. Let's look at our graph. The asymptote of the Q value is the horizontal one, which is minus 1, and the P value, which is minus 2. But remember, we want P is gonna be the original P, which is 2. I hope you understand. Then our P is positive 2, while it's positive 2. So it's positive 2, while our Q is minus 1. I hope you understand. Point 2. Calculate the value of A. When calculating the value of A, check. If you want the value of A, already we have P and Q. We can use this coordinate that the graph passes through, which is minus 4 and minus 5 over 2, in order to calculate the value of A. And let's use those coordinates. 4.2, we have coordinate of minus 4 and minus 5 over 2, where the graph says f of x is equals to A divided by x plus P plus Q. Then we all know f of x is the same as y, equal to our A divided by x. Our P, original P, is plus 2 minus 1 is our Q. The way we see our y, we substitute with minus 5 over 2. 5 over 2, which is equals to A. Over where we see x, we substitute minus 4 plus 2 minus 1. And transpose minus 1 to the left. We're gonna have minus 5 over 2 plus 1, which is minus 3 over 2, which is minus 3 over 2, equal to A over minus 2, which is 2 minus 2 over 4. Then minus 3 over 2 is equals to 1 over negative 2A, and A will be equal to, then you see, minus 3 divided by 2 divided by 2 divided by minus 1 over 2, which is equal to 3. I hope you understand. It is simple. And let's look at 4.4. The 4.4. As always, 4.4 is a determined equation of axis of symmetry. Axis of symmetry. Where m is less than 0, already consider our axis of symmetry is a negative gradient, which is represented by y equals to mx plus c. And always when dealing with axis of symmetry, we used our asymptote, which is -2 and -1. I hope you understand what I'm trying to say. Now our gradient is equal to -1 already because it is left hand. Then we're gonna substitute -2 where we see x and minus where we see y. Then we have -1, which is equal to -1 times what? Times -2 plus c. Then we solve for c. We're gonna have 1 minus. This one gives you positive 2 plus c. C is equals to what? C is going to be equal to minus what? Minus 3. I hope you understand. That means our equation will be the first as y is equals to minus x minus 3. I hope you understand. Very simple. Always when dealing with axis of symmetry, make sure that you use your asymptote, the given asymptote. Then check 4.5. 4.5, question 4.5. So write down the equation of the asymptote if f of x plus 4 1 over 2. And our graph says our graph is represented like this. F of x is equals to 3 over x plus 2 minus 1. Already if you see plus, already that it is moving to the left. And if you check, our y asymptote is not affected, only the x asymptote is affected to the left. If it is affected to the left, we must have a negative. Then after a negative, where you see x, you can substitute by 4 1 over 4 or times 1 over 2 plus 2, which is 6.5. That means it moved 6.5. Our asymptote will change to 6.5. I hope you understand what I'm trying to do. Then let's look at question 8. 8.1, given the f of x, which is equals to minus 2x squared plus 1. The 8.1.1 is determine the f of prime in what? From or not in, from first principle. Is the long way of derivative, which is referred as f of prime of x, which is equals to what? Which is equals to limit when h approaches 0, then f of x plus h minus f of what? F of x divided by what? Divided by h. When you go to your f of x, which is minus 2x squared plus 1, say limit when h approaches 0. And when you see your x, you substitute with x plus h. You go to our original graph, which is minus 2 times your x, which is where you see x, you substitute with x plus what? Plus h. But don't forget what? Squared. Plus what? Plus 1 minus, since you see minus 2, open brackets, the original f of x, which is minus 2x squared plus 1 divided by 1 divided by h. I hope you understand. And let's go on. Let's keep going. We're gonna have a limit when h approaches 0. Approach 0. Then we have minus 2x plus h plus 1 minus 2x squared plus 1, which is our original equation. Let me check it. And that's our original equation. Our original equation divided by h. Then we will have a limit when h approaches 0. Until then you start solving. Do not forget squared. Then we have start solving the numerator. We have a minus 2 times. We already know x plus h squared is the same as x squared plus 2xh plus h squared plus 1 minus open brackets 2x squared plus 1 divided by h. Why? Referring to what? Referring to x plus h. 2 pairs of brackets. 2 pairs of what? Of brackets. Gives you x squared plus 2xh plus h squared. Then we're gonna have limit when h approaches 0. And I have minus 2x squared. Minus 2 will affect everything in the bracket. Minus and positive, which is minus 2 times 2, which is 4xh minus 2h squared plus 1. Then minus times positive, which is minus 2x squared minus 1 divided by what? Divided by h. If you sorry, there is a minus here, causes it to be positive. I hope you understand. Then minus 2x squared and minus 2x squared goes to town. Minus 1, positive 1 and minus 1 goes to town. Then we will be left with limit when h approaches 0 minus 4xh minus 2h squared divided by what? Divided by h. Then let's go on. Then we will be left with limit when h approaches 0. Equal sign. Okay, let me. Is equal to limit when h limit when h approaches 0. We'll be left with what? Minus 4xh minus 2h squared divided by h. Then if you look at the numerator, there is h and there is h. You can take out the common factor of h. If you limit when h approaches 0, gonna have if you take out the common factor of h, you will be left with minus 4x minus 2h divided by h. And h and h goes to time. We have to limit from h equals 0 below to minus 4x minus 2h. And the f prime, now the f prime will be equal to minus 4, where minus 2h approach 0, which is minus 2 times 0, which is equals to what? To 0. I hope you understand. Even if you use differentiation rule, we were given minus 2x squared plus 1. Then the derivative of this graph is the same as minus 4x plus 0, which gives you minus 4h, which is this one. I hope you understand. Then let's look at 8.1.2. Hence they calculate the gradient. They want the what? They want the gradient. When calculating the gradient, always in the calculus, make sure you have the derivative of the graph. Always the derivative of the graph. They want the gradient of the tangent at f. If x is equal to what? If x is equal to minus 1 over 2, you must get your graph which is minus 2x squared plus 1, and do the derivative which is minus 4x. And where you see x, you substitute with minus 1 over 2. It's going to be minus 4 times minus 1 over 2 is equals to half of 2, which is half of 4, which is 2. The original answer. I hope you understand. Ask me if you don't understand. I will reply in the comment section. Then we look at 8.2. 8.2, but determine the derivative. The derivative, they gave us f of x, which is equals to 3 to the cube root of what? The cube root of x squared plus 1 over 4 x to the power 4. When doing the derivative, make sure that anything that you derivate respect to is not placed at the denominator. Make sure that it is in the numerator, and try all by means to eliminate the cube root and square root in order to derivate. So let's try first to eliminate the square root. We all know that from Greener we learned things called surge, where it is the cube root of x squared is the same as x squared. It's the same as it is the same as x squared to the power 1 over 3 plus. Make sure that everything that you derivate is in the numerator. You have x, you're gonna have x to the power minus 4 over 4 in the numerator. From the denominator to numerator, even the sign changes. Then it's the same as x2 to the power 1 over 3, the same as 2 over 3 plus x to the power minus 4 divided by 4. Then you start derivating the f of prime of x, which is equals to 2 over 3 x. Then you take that power of 2 over 3, you reduce by 1, plus you take the power of negative 4, you bring it down, then you take minus the power of minus 4, you reduce by 1, then you divide everything by what? By 4. Then everything by 4. Then you will be left with 2 over 3 x to the power. And you see 2 over 3 minus 1, which gives you minus 1 over 3 minus 4 to the power minus 5 divided by what? Divided by 4. With 2 over 3, then since it is a negative power, you bring it down and you have x to the power 1 over 3 minus 4 divided by 4, which is 1 times x to the power is the same as 1 over x to the power 5. That's how we derivate. That's how we derivate, guys. That's how we derivate. That's how we derivate. Let's look at 8.3. 8.3. We are given h of x equal to what? Equal to ax squared, where a is greater than 1, 0. Then you determine the value. You want the value of a. On the value of a, where h, the inverse of the graph of 8, is equals to the h prime of 4. In this kind of question, you must always check what you are given. Already we have h of x, which is equals to a x squared, where a is greater than 0. But they said the inverse of the graph. The inverse of the graph is called the h prime of what? Of the graph. We can first get the inverse of the graph. We already know h of x is equals to ax squared, where h of x is represented by y equal to ax squared. And when dealing with the inverse of the graph, you must always know that y and x must swap. We're gonna have x equals to y squared. Then after, make sure that the y is the subject of the formula. We're gonna divide it by what? By a. But in order to do y subject of the formula, you will be having x over a, which is equals to y squared. We don't want y squared subject of the formula, we only need 1. Then you're gonna introduce square root. Therefore y is equals to plus or minus the square root of what? X divided by what? X divided by a. But remember, what did they say? The inverse of 8. So that means you're gonna have y, which is equals to the square root, where you see x, you substitute 8 divided by a. Hope you understand. This is the derivative. It is the inverse. Then now we are gonna look at the derivative. The derivative of h of x is equals to the graph of h of x equals to ax squared. But the derivative of the graph with respect to x, we're gonna have 2ax. But where we see x, we substitute with 4 since a is the derivative. We're gonna have h of prime of x, which is equals to 1 to 2a times what times 4, which gives h prime of x 8a. 8 what? 8a. But remember, they said inverse of 8 and h prime of 4, they are what? They are equal. So we can equate these two. We can equate these two questions. We can equate them. Then you can equate them. Then you tell them that. Let me check them again. Which is you can say the square root of 8 divided by a is equal to what? Is equal to 8a. To 8a. Then you solve for a. If you want to solve for a, you can introduce the square. If I introduce the square and introduce the square, I'm gonna have 8 divided by a is equals to 8a times 8a, which is 64. Which is 64a squared. Then since there is a fraction, I must do fraction, do cross multiplication. 64a to the power 3, which is equals to 8. Then if I want to solve a, I'm dividing by 64. 64, guys. Okay, let me fix it. 64 divided by what? By 64. Where a to the power 3 is equals to 8 divided by 64. But I don't want a to the power 3. I want a. So I'm gonna introduce the cube root. I'm gonna introduce the cube root of 64 of 8 divided by 64. Then our a is equals to, then you see the cube root. The cube root of 8 divided by 64. Is our a is equals to what? Equals to 1 over 2. I'm sure that you understand. Please ask question if you don't understand. I will reply in the comment section. Then please go and try this kind of question. First, the principle. Number 1, the first principle of f of x, which is equals to 2 over x. Number 2, the derivative. Please find the dy over dx of the square root of x divided by 2 plus 2 pi x. And number 3, then try the d into the f of x, which is equal to the square root of x to the power 3 plus 2 the square root of 2 divided by 1. Sorry, I meant 4 divided by, the square root of x to the power 4 divided by 2.